Hi, this is Mrs. Gray coming to you from DeWitt Middle School. I am the Blue Team science teacher, and Mrs. Steam and I decided to put a quick video together to show you just the effects of the sun hitting the earth at different angles and with different intensities. So when the sun hits the earth, it's providing a lot of the energy that we use for everything. So it gives the energy to the plants. The plants are eaten by sometimes us, sometimes animals like cows, and then we turn around and eat those animals. The sun is what gave us, it gave us the energy to create fossil fuels. So that's kind of a longer story, but almost all of the energy we get comes from the sun. And so today we're going to take a look at how the sun hits the earth differently in different locations. And this is going to affect the temperature of an area. It's going to affect how long our days are, how long our nights are, when the sun rises and sets. The way that the sun hits the earth actually drives our winds. So on a windy day, you can think that that's because the sun has caused this motion of air. It affects the currents in the ocean. And it also is part of the reason that we have seasons, the reason that we experience a summer, a winter, a spring, and a fall. So today we're going to use the projector to represent the sun. So I've got the projector on here, and it's actually projecting dots, which we're going to use to represent the amount of energy. And so just think of those dots as some energy, and the more dots that hit a location, the more energy is going to hit that location. And so you can see when we project that onto a flat surface, all the dots are pretty evenly spaced out. Actually, they're very evenly spaced. You could play the game of Connect 4 on here if you were bored. But when we put a globe in front of our dots, so let me grab my globe. All right, so now we have the globe in front of the dots. And so you can see that those dots are not evenly spaced anymore. So if we look closely toward the middle, the equator, down by like Mexico, you can see those dots are pretty close together, and they get a little further apart as you go further up. And then you can see that up near Alaska, over here, they're far more spaced out. And so that's because less of the sunlight is actually hitting those areas. You can also see that those dots are a little bit more spaced out, and that just represents the fact that that energy is being spread out over larger areas. And so what I have set up right now is actually spring in North America. So this is sort of like what we would be experiencing right now. And so in areas like Mexico, they're going to have more energy. And as we get up toward Michigan, it's a little bit less. And then in Alaska, which is even further north, there's even less energy. So we're going to ask you a couple questions related to this energy situation. And I just want to show you quickly how we collected this data. So I'm going to go ahead and set my phone down right here. Okay. And so what we did is we have some sticky notes, and there's a sticky note up here toward the northernmost part of the globe, which we're going to call the polar region. We've got one that's way down here by the equator. This one we're going to call the tropical region. And then we've got one in the middle. This is going to represent the mid-latitudes. And so Michigan, if you were to rotate, is in the top part of the mid-latitudes. So if you're thinking about Michigan, you would be thinking about this center sticky note here. And so when we collected data, we counted the number of dots on each sticky note. Okay, so you can see, even just looking at it from far away, that there are lots of dots on that middle one and a little bit fewer on the top one. So here we go. Let's take a look a little closer. So we could count up those dots in the middle. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 30 or 31 dots at the equator. If we go to the mid-latitudes, it's going to be a little less. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We've only got 20 dots as opposed to 30. And if you go to that northernmost part, this is representing the polar region, so this would be Alaska. We've got 1, 2, 3, 4, 5, 6. So in the spring, Alaska is only receiving 6 energy dots in our model compared to the equator, which receives 30 energy dots. So almost 5 times as much energy is hitting the equator in the springtime. And then you'll see that this can change throughout the year. So if we change this to summer in the northern hemisphere, so our axis is tilted toward the sun, it becomes a little bit more even. So we could count those up again. I'm not going to, but you'll get the data. But notice now, instead of just 6 at the northernmost part, we've actually got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 energy dots now that it's summer in the polar region. So this video is to help give you an idea of how we collected that data you're looking at, and to also give you a visual of how energy hitting the Earth from the sun is actually not evenly distributed. It's being spread out over different parts of the Earth in different ways.